Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman. Hey, Ben, how are you?
Hey Simon, hey fellow Econauts, how's it going? Today we talk about space elevators.
All right, so what is a space elevator and how does it work?
I think everybody knows what an elevator is, but just in case somebody doesn't know it, so we have a vehicle, a climber, that climbs along a rope. That's pretty much the same principle for a space elevator. The difference now is that the cable is anchored into the ground and the other end is floating beyond geostationary orbit, and in a way that this sort of counterweighs the cable, and it stays sort of in position at all times and rotates with the same speed as the Earth rotation. And then from there we have our climber going from the ground. We can fill it with people or cargo, and it can go up and down.
Why would we build a space elevator and what are the potential benefits?
As we have mentioned a couple times before, launching with a rocket from Earth is always a little problem because we need to use about 80% of energy of fuel just to reach orbit. That means we don't have all that fuel available once we are in orbit, and we have to either refuel it or we have to build it in a way that we can use as little fuel as possible from there onwards. That means that our missions in space are somewhat limited by how much fuel we have available once we are in low Earth orbit. With the space elevator, we won't have that issue anymore because now we can send that climber up. The climber could work either with concentrated laser or with solar panels and could then just climb, and could transport spacecrafts or people into the spacecraft or fuel into low Earth orbit. So we would sort of avoid using so much fuel. And also the other advantage would be that we can go up and down in a very frequent manner. So we could use the elevator not only, at certain conditions, at certain positions and so on. We could build the space elevator pretty much anywhere on Earth as long as the counterweight in space is counterweighing the cable and keeps it in place. So this is sort of the real benefit from using a space elevator. Thus the availability, the frequent use of it, and that we avoid using fuel to get into space. The other benefit might be, if we don't only think of Earth, but also on other celestial bodies, that we could also build space elevators, for example, on the Moon or on Mars, once we are building a permanent presence there.
What are the main challenges building a space elevator?
Building a space elevator would require to find a material that is light enough and at the same time strong enough to maintain the tension for about 45,000 kilometer long cable. So the own weight of that cable would be immense, and then on top of that, having something climbing along it would be also, extremely hard to find that material for. And as I said, at the same time, it needs to be extremely light to be brought into space in the first place. Secondly, having such a construction reaching into space would also mean that there's now a potential target for, if we have global conflicts, for example. And also at the same time, it's now a permanent obstacle. So if we have any low Earth orbit satellites, or also, we are going beyond geostationary, anything in between could now potentially collide with that cable in space, and obviously is a huge problem, a huge risk for any satellites that are already orbiting in that region. So I mean, that is manageable, of course. I think the biggest hurdle really is the material, finding the material that can actually maintain, as I said, the strength and the weight for such a construction. Then the second point would be that we have to build actually a climber. I think the climber is less of a problem, but still it's not yet really solved that problem, because we would need something that can, either with solar panels or however, you want to transport the energy. Obviously, the cable itself cannot be used also as an electricity cable. just before you might think of that, because then we would already use something that conducts electricity, which would potentially make the cable or the tether heavier. So don't be fooled by the name cable. The cable is really just like, it's a tether. It's not meant to conduct electricity in this case. Or maybe, but as I said, it's already hard enough to find a material that is lightweight and strong enough to maintain that. So adding more requirements on the cable would be maybe a harder task to find a solution for.
Based on our current technology, would you say that a space elevator is a realistic goal?
I personally believe the space elevator on Earth is not a realistic goal. I think on Earth we still have rockets that can deliver our cargo. We need to, in my eyes, bet on heavy launch vehicles just to sort of increase the benefit for the logistics, for the economic of scales. I think it's too hard to find that material. I would not like to disencourage the idea in general, but I personally believe that on Earth we will never see a space elevator. I think on the moon it might be a worthwhile consideration, just because the moon is way smaller. We don't need that long of a cable and so on. And maybe in the future there might be a way, but right now I don't think there's any material that we could use to build a space elevator.
Well, building a space elevator seems to be like an interesting challenge for us. I believe that we will see that on the moon rather than here on Earth. If you like this episode, please don't forget to leave a like and subscribe if you haven't already.
And if you feel as elevated as we are about this topic, don't forget to hit the notification bell. Also, check out our channel. We have already quite a number of interesting episodes there.
And I will see you next time. Bye bye.
See ya.